since we're going to be given a rectangular one, they're going to have x's and y's in them. How do you convert the x? How do you convert the x? How do you convert the x? R cosine theta. How do you convert the y? R sine theta. So anytime today I see an x or I see a y, that's automatically getting substituted in. Last thing you're going to need, and this is actually from first semester, when we're getting ready for the Regents exam, is an identity. All right, the one identity we always worked with, and some of you probably don't remember, some of you may. Sine squared plus cosine squared. Anybody remember what that was equal to? 1. Sine squared plus cosine squared equals 1. We'll be dealing with that today as well. All right. Deep breath. We ready to begin? All of these today, leave your answers as R. So I need your help solving all these equations for R. R equals, R equals, R equals, R equals. That's what I need at the end of all these 4 right today. All right, R equals something. Here we go. Convert x equals 7 to a polar equation. What variable do you see up there? X. What's x's equivalent in polar? R cosine theta equals 7. All of these are being solved for R. What would you like to do on both sides to solve for R? Divide by cosine theta. So the equation in polar will be R equals 7 over cosine theta. Solve for R to get into the polar equation. Because here's what, hey, and I want to just stop real quick on this easy one to show you where this is going. Because you're probably like, that doesn't make any sense to me, but I'll just believe whatever he says. I don't want it that way. All right? This is where we're going. Like, say if I asked you to graph this in the next week, probably next week we'll start graphing these. Here's what you're going to do for me. You guys are going to set up a table of theta and R, and you're going to say, okay, what if theta is 90? You're going to plug in 90, get what, say you get 5 out. Do you guys know how to graph 5, 90 on the polar graph? Right, 90, count 5 circles, and then there's your point. That's where we're going with this. Okay, you plug in the angle, you get the R value out, you plot the point. That's where we're going with these. Okay, everyone good? Whether you cared or not, but I do. Okay, everyone ready for the next one? Convert this one to polar. What do you guys see up there? Which variables do you see from the rectangular? X and Y. All right, so what do you want to substitute in for X? R cosine theta plus R sine theta equals 5. Ooh, but you guys know you got to solve for R, and there's 2 of those suckers up there. So here's the point we're going to get to. How do I make those 2 R's into 1? No, you can't combine. I'm telling you right now, you can't combine them. I'm going to factor an R out. It's a GCF. Oh, yeah. I'm going to take a GCF out. What's common in both? So I could take those 2 now, and it becomes 1. And what do you, when you take out an R or factor an R out, it becomes cosine theta plus sine theta. That's not the identity I put up there because these aren't squared, so don't try to be a hero. Okay, don't try to be a hero. All right, how do you get the R by itself? It's being multiplied by this whole thing. Divide everything by, both sides by, cosine theta plus sine theta. Yep. So what's your polar equation now? R equals 5 over cosine theta plus sine theta. There's my polar equation. Everyone all right? Okay, ready to get a little tougher. X squared plus y squared equals 9. Okay, everyone see an X? What's going in there? What's going in for the X? R cosine theta. That's just for X, and then I'm going to square it. I'll work with you on a second on that. And then in the second one, what's getting plugged in for y? R sine theta squared equals 9. All right, I see you. All right, how do I square? I square both of them, the r and the cosine, the r and the sine. Ready? So it's r squared cosine squared theta. Everyone see what I just did there? I squared both pieces in there. Because it's very similar, if you're not, it's very similar to this. What's 3x all squared? Oh boy, maybe that was a little too. 9x squared. How'd you get 9x squared? 3 squared, x squared. R squared, cosine squared. Next one, what's that going to turn into? R squared and sine squared theta equal to 9. We're trying to solve for r. Look back at the last problem. Thoughts now. Take out a GCF, which is now not r, but r squared. Yep. Now watch the magic that's about to happen when you take out an r squared. Okay, ready? What's left? Cosine squared plus sine squared. And what's that identity you wrote at the top of the page? What can I substitute now in for cosine squared plus sine squared? 1 times r squared. This is 1, right? That's at the top, right? R squared, cosine squared plus sine squared is 1, so I substituted in 1 times r squared. Go. What do you mean? No, because look, I got two. When I square, I have two pieces: cosine theta and r. Correct. Yes. Yep. Guys, please stop. Go ahead. This right here is not x plus y. It's not the same. It's not the same. Okay. Equal to 9. So what's your polar? R equals 3. Yeah, R equals 3. Go ahead, Austin. Okay, you ready? Good. That's a great question. Got your calculator with you? Okay, pick any angle you wish. What angle are you picking? 45. You ready? Do cosine of 45. In parentheses, do cosine of 45 for me. Square it. You get a decimal, right? Then do the sine of 45. Square that and add those two numbers together. You're going to get 1. Okay, that's why. And it works for any angle you pick. Okay, it works for any angle. 45, 55, doesn't matter. Everyone all right? What's your deal, Shannon? I didn't think so. Others? Yep, now I'm getting a little attitude now. Yep. Fourth quarter seniors. I'm better than every teacher. Yep. All right, here you go. Let's do this first conversion here. X, what are we plugging in? R cosine theta, all squared. Plus r sine theta, all squared. Oh, we got a little something on the right side, just not a number. So 4 times Okay. What, Hannah? Here we go. Where? What am I? What's your question? Yeah. Are you done? Whoa, buddy. Here we go. Yep. Here we go. All right. Rattling today. All right. Here we go. I know. Juniors thinking they're seniors today. Yep. Okay. Easy back there. All right. Here we go. Let's just finish this up. R cosine squared. We know it's R squared cosine squared theta plus R squared sine squared theta. No big deal. And then what are we getting on the other side? 4R cosine theta. What do you want to do? Take the R squared out. Yep, you got it. Take the R squared out, factor it. And very similar to the last one, but we have some stuff on the other side to take care of now. So we'll just keep that 4R cosine theta. You're killing me, Goof Troop. You're killing me. Thank you. Inside the parenthesis. 1. So what's on the left side? Okay, we're okay with that because I'm going to take this a little different direction now. R squared equals 4R. Here we go. R squared equals 4R. All right, now look. Take a look at where we're at now. I know many of you right now, you're like, oh, just square root, we're done. That doesn't help me, though, because it's got to be solved for R. And I don't need another R on the other side. You see what I mean? I need R equals something on the other side with a theta, but no other R's. Okay, I need R equals something over here without, I need just R on one side, all by itself, no more R's. How many R's you got on the left side? 2. Stop. How many do you have on the left side? 2 of them. How many do you have on the right side? So can I get rid of one of these and this one? R squared, how many do you have right now on the left side if I divide by R? And what happens to the ones over here? See ya. 4 cosine theta. Now look, are we going to be able to handle this tomorrow when you're here? Substitute, look to factor, make sure there's an R left on one side. If you're not here tomorrow, no excuses, you can get it done.